5-2 goes over right triangle trigonometry, which means we're working with sine, cosine, tangent, cosecant, secant, and cotangent. Your sine is always going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. Tangent is always opposite over adjacent, so kotoa. Cosecant is the inverse of sine, so instead of it being opposite over hypotenuse, flip it, hypotenuse over opposite. Secant is the reciprocal of, it's not the inverse, it's the reciprocal of cosine, so it's going to be hypotenuse over adjacent, and then cotangent is the reciprocal of tangent, so that's going to be adjacent over opposite. When you find your opposite, your adjacent, your hypotenuse is always the longest side length. It's the one that's directly across from that right angle. The opposite side length is going to be opposite of theta, and then your adjacent is going to be the other side length that you don't have labeled then. So if you look here at, let's look at the next page to see, look at these. So with these two triangles, to find out which ones are opposite, are hypotenuse, or adjacent, look at where the right angle is on the triangle. Across from that is going to be your hypotenuse. Look at then to see where theta is. Theta is in that bottom left-hand angle. So the side length opposite of that is your opposite. And then the one that's missing, or the one that hasn't been labeled yet, is your adjacent. If you use that every single time, there's no way that you can get these mixed up. Okay? So with this, we're going to move into our first example. We're going to find the 6 trigonometric ratios of angle theta in this triangle. So we see that theta is in that bottom left-hand angle of this triangle. You want to remember, if it helps you, so kotoa. From here, you would just take the reciprocals of these for cosecant, secant, and tangent, and cotangent. So, your sine, let's do this first. Let's label these before we do anything else. Looking at this triangle, you want to find the side length that's opposite of your right angle. Your right angle is always going to have that little box on it. So, opposite of that gives you your hypotenuse. So, the 3 is your hypotenuse. Then look at where theta is. Opposite of that is the 2. That's your opposite. Adjacent to that is that square root 5. That's your A. So you have your hypotenuse, your opposite, and your adjacent now. If it was me with all of these, what I do first is I tell myself, okay, sine is opposite over hypotenuse. If I look at my triangle, my opposite is 2. My hypotenuse is 3. So my sine is 2/3. From there, cosine is adjacent over hypotenuse. So if I look at my triangle, my adjacent was the square root of 5. My hypotenuse is 3. That's perfectly fine to keep because my radical is not in the denominator. I don't have to rationalize it at all. So the square root of 5 over 3 is my cosine. My tangent is opposite over adjacent. We said opposite is 2, adjacent is the square root of 5. I cannot leave the square root of 5 in the denominator. I have to rationalize that. So I'm going to multiply the top and the bottom of this fraction by the square root of 5. This is going to leave me with 2 square root 5 over 5. So my tangent is 2 square root 5 over 5. From here, I got to still find my cosecant, my secant, and my cotangent. My cosecant, which is labeled CSC, is just the reciprocal of sine. So instead of it being opposite over hypotenuse, that's hypotenuse over opposite. We said hypotenuse is 3, opposite is 2, that's 3 over 2. Our secant is the reciprocal of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. My hypotenuse is 3. My adjacent is the square root of 5. So I have to rationalize this, multiply top and bottom by the square root of 5. This gives us 3 square root 5 over 5. And lastly, we work with cotangent, which is the reciprocal of tangent. So instead of it being opposite over adjacent, it's adjacent over opposite. Our adjacent is the square root of 5. Our opposite is 2. So to put this all together, our sine is 2 over 3. Our cosine is the square root of 5 over 3. Our tangent is 2 square root 5 over 5. Our cosecant is 3 over 2. Our secant is 3 square root 5 over 5. And our cotangent is the square root of 5 over 2. So all of this is our answer for this one question. The next part of your lesson works with using a calculator in order to find specific values of these trig functions. Now, you need to realize with these, your calculator, if you're using a scientific calculator, you're only given sine, cosine, and tangent as buttons. In order to find the cosecant, it's the reciprocal of sine. So you would just do 1 divided by the sine of whatever you're finding. In order to find the secant, it's the reciprocal of cosine, so you would just do 1 divided by the cosine of that degree. And then your cotangent is the reciprocal of tangent, so it would just be 1 divided by the tangent of that degree. When you find the sine, cosine, tangents of these, they most likely will be given to you in degree form. If they're not, it's totally okay. You just got to remember to put that pi in your calculator. For example 3, we're using a calculator to find these values. For example A, we're given the tangent of 40 degrees. So in your calculator, only thing you have to do is hit that tangent button, type in 40, close your parentheses, and hit enter. It gives you 0.839099631. We're going to round to the 4th decimal place. So this is going to give us 0.8391. Our next example, we have the cosine of 20 degrees. So in your calculator, just type the cosine button, type in 20, close the parentheses, and hit enter. It gives you 0.939692621. Again, with this one, we're going to round to the 4th decimal place, so it's going to be 0.9397. For example B, we have the cotangent of 14 degrees. This is the same exact thing as putting into our calculator 1 divided by the tangent of 14 degrees. If we do that, we get 4.010780934. Again, we're going to round to the 4th decimal place, so this just gives us 4.0108. And lastly, for this example D, we are given the cosecant of 80 degrees. The cosecant of 80 degrees is the same exact thing as the reciprocal of sine, so this is going to be 1 over the sine of 80 degrees. Using our calculator, we do 1 divided by sine 80, close the parentheses. This gives us 1.015426612. We're rounding to the 4th decimal place, so this is just going to give us 1.0154. So with every triangle, you have 6 parts. You have 3 angles, you have 3 sides. In order to solve a triangle, it just means to determine the parts that you have from the information that's given to you. So you want all 3 sides and all 3 angles. A triangle is 180 degrees. So if you're given 2 side length or 2 degrees, in order to find the missing one, add the 2 degrees that you have, divide it, and then subtract it from 180. For the angles, for the side lengths, you're going to most likely be given at least 1. Find out if that's your opposite, your adjacent, or your hypotenuse, considering where theta is, and then work from there. You're going to be taking the sine, the cosine, or the tangent of these values to get your missing parts. If we look at example 4, we're told to solve the triangle ABC that's shown here. So with these, you have angle A, you have angle B, you have angle C. You're given angle A and angle C. The angle A is 30 degrees, angle C is 90 degrees. If you think back to geometry, think 30, 60, 90 triangles. If you don't remember that, add up the ones that are given, 90 plus 30, subtract it from 180. That angle B is 60 degrees. So your angle A is 30 degrees, angle B is 60 degrees, and angle C is 90 degrees. That's part of our answers. We're halfway there. From here, we need to make sure that we have angle A, side length A, side length B, and side length C. In order to find that, we look to see the degree that's given to us. The 30 degrees is what's given to us. So that's going to tell us what our opposite, our adjacent, and our hypotenuse is. The 12, since it's across from the right angle, is our hypotenuse. Side length A, since it's opposite of the 30 degrees, it's opposite. Side length B, it's next to the 30 degrees, it's adjacent. So in order to find the angle A, we're going to be doing opposite with the one we have, our hypotenuse. Opposite over hypotenuse is sine. So to find that, we're going to use the sine of 30 degrees is equal to opposite, which we said was A, over hypotenuse, which we know is 12. We got to find for A. Think of it as x. Solve for the variable. We're going to get rid of the 12 in the denominator by multiplying it to each side. It cancels out on the right side, so we just have A is equal to 12 times the sine of 30 degrees. We use our calculator for this. Type in 12, your sine button, then 30, close the parentheses and hit enter. It gives us a side length of 6. From here, we still have to find for side length B. If we're working with side length B, use what's given, not what we found, use what's given. B is our adjacent. The side length that was given is 12. That's our hypotenuse. Adjacent, hypotenuse, that works with cosine. So if we do the cosine of 30 degrees, remember, adjacent over hypotenuse, that's B over 12. We multiply each side by the 12 to get rid of that fraction, and we just have B is equal to 12 cosine 30. Use your calculator. 12 cosine 30 gives us 6 square root 3. So with the missing parts that we were trying to find, we also found our side lengths. So our side length A, is 6. Our side length B is 6 square root 3. And our side length C was given to us of 12. So now that we have all 6 parts here, we have our angle A, which is 30 degrees, angle B is 60 degrees, angle C is 90 degrees. Side length A is 6, side length B is 6 square root 3, and side length C is 12. Next, we're going to look at angles of elevation and angles of depression. With these, you're looking at the horizontal line and the line of sight. If that line of sight opens up from the horizontal line, you have an angle of elevation. If it opens down from that horizontal line, then you have an angle of depression. With these, what I just said is exactly in this slide. So we're going to look at a figure that's given to us and figure out what we need to use sine, cosine, tangent in order to find the height. So this tells us that a giant redwood tree casts a shadow of 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. Now, this picture is given to us. It's not always going to be given to us. So you got to think of this as like you have a tree. This is going to be great artwork here. It's on the grass. it casts a shadow that's 532 feet long. So this here is casting a shadow that's 532 feet long. From there, it tells you the angle of elevation. So it's not from the top of the tree. The angle of elevation, it's an angle that goes up, would be here, is 25.7 degrees. We're finding the height, so we're finding x. Think about what you have. This is the right angle. So this across from it is going to be your hypotenuse. Opposite of the angle that you are given is x. That's what you're finding. And then adjacent to that is the 532. So you're working with opposite and adjacent. Opposite and adjacent is tangent. So we're going to take the tangent of the degree, which is 25.7, and set it equal to our opposite, which is x, that's what we're finding for, or h, over our adjacent, which is 532. In order to get x by itself, or h by itself, if you put h in, that's fine, we're going to multiply each side by 532. We're going to use our calculator. So 532 times the tangent of 25.7 gives us 256.0343095. It doesn't tell us what to round to, but I'm going to round to the nearest foot. So this gives us that x, or our height, is 256 feet.